Today's topic, we're going to go over the homework questions from the forum and from last week, and then we're going to talk about lists. And this is really, really going to open up the chance to talk about more complex data structures. But you're going to see that everything we've done so far has been leading to this, right? Like a lot of the things that we've done so far are going to fit into like lists and how they work. So it's not for naught that we've been talking about other things so far. So the plan is basically we'll go over the homework. We'll talk about lists. If you already have questions like based on things, feel free to put them in the chat. I'll try to get them sort of like between between the homework and the new stuff. By the way, here and there, people are asking me a few questions. One question that I keep getting is how many sessions are we going to do? And my plan at this point is to do about probably 12, 13 sessions or so. My guess is that'll get us to where we want to go. And the plan is basically this week we're going to talk about lists, and then we're probably depending on what we do this week, next week we'll probably do like lists and strings, sort of going back and forth between them. So you actually do all sorts of really cool stuff with that. Talk a little bit about tuples. Then we'll talk about dictionaries, then we'll talk about files, and then we will talk about functions. And that's basically where I see this course ending. So my guess is another like 5 sessions or so is probably going to be about right. Hi, oh, it's so great to see so many people here. Fantastic, fantastic. Oh, no. Well, that's like still good, just not as exotic. What can I say? I'll have a 40-minute car drive from where I live. The other question that people had that I got an email from a bunch of people is, how long will the videos be available for? And the answer is forever, basically. I switched to this platform known as Podia for doing all of my online teaching, or I should say for like all of my like selling of courses and making things available and so forth for products, probably about 2.5 years ago. And I really, really, really like them. I am not interested in switching away from them in any way, shape, or form. So as long as I stick with them, the course will continue to be available. So a few good years at the very least. And if they continue to do well, serve me well, believe me, I'm very happy to keep them around also. All right. Well, it's already 10 Eastern, 5 my time. So let's dig in to the homework questions that I had. I put in the forum, and that'll give people a chance to also ask some other questions about things. And then we'll dig into lists. So let me move this over to my other screen. Share screen to my Jupyter notebook, which is there. Okay, that looks good. Yes, click on the share button. Okay, and I'll pop out Q&A and pop out the chat, which is somewhere. Somewhere. There we go. Very good, very good, very good. Okay, so and then I have to actually find the questions that oh no, they were in that window. There we go. Okay, so I'm going to copy this. Oh, it looks like I didn't even like finish writing one of them. Ha! No one mentioned that. It's like an old problem that I have. Back when I was in at university, people would laugh at me. I was at the student newspaper there, and I would like forget to finish sentences I was writing. So they laughed at that a lot. And sure enough, seems like it's still going on here. Okay, so the first question, I'll just like split this up. First question, ask the question, a user to answer a sentence. Print the number of vowels, digits, and other characters that were in the user's, and we'll say sentence. That changes everything, right? Now actually knowing what we're supposed to do. So how are we going to do this? Well, first of all, I want to count these things, right? So if I want to count these things, I'm going to need variables for them. And I'm going to need to set up these variables in advance. You can't add to a variable that doesn't exist. So I'm going to say here something like that. I'm going to say vowel, or let's say vowel count equals 0, and digit count equals 0, and other count equals 0. Oh, it even aligns really nicely there, like just that number of things. Okay, excellent. So now what? So now we're going to ask the user to enter a sentence. We're going to say s equals input, enter a sentence. I'll even strip that to get rid of the white space on either side. And remember, the way this works is input is a function that when we execute it, returns a string. So you can think of it as being the call to this function is being replaced by a string. And so if it's replaced by a string, we like the highlighted thing here, we can then invoke the strip method on that string, an anonymous string, and then that removes the white space from either side, and then we assign that back to S. So we know that there are going to be no extra white space characters on the other side there. Did this just start at 10 a.m. Eastern? It did. Yes, it did. So just like, like 2 minutes ago. And in conclusion, okay, anyway, So anyway, so what am I going to do now? So now I have to go through the sentence character by character. So I'm going to say for one character in S. Now, how do I know that I'm going to get one character at a time from S? Because the way that strings work in Python is that when they're put inside of a for loop, they give us one character at a time. So if I just say here print one character, we're going to get the character. So if I say this is a test. So it's just going to print out each of the characters there. It doesn't matter what they are. They could be letters, they could be numbers, they could be spaces, they could be punctuation. All those things are possible. Okay, but I don't want to just print them out. If I don't want to print them out at all, I want to count them. So I'm going to do some analysis here. So I'm going to say here, if one character in AIOU, is this character in that string? So I'm searching little thing in big thing. And if it's true, then I'm going to say here, vowel count plus equal 1. Oops, not 12, 1. I mean, I like vowels, but not that much. And then I can say here, elif, but if that's not true, then what am I going to do? Well, I'm going to say here, of one character is digit. And notice these tests look different. These conditions look different, right? If one character in AIOU, that's going to return a true or false value, but it's using the in operator in Python. Whereas here I'm saying one character dot is digit. That's a method that also returns true or false. And then I can say here, well, if it's a digit, then I'll say here, digit count plus equal 1. Is it possible for something to be both this and that? No. But, well, I mean, in theory, you could have two overlapping conditions, but the first one that's found to be true is the one that fires. So if it's a letter from here, then it's a vowel count. If it's a digit, then we update digit count. And in all other cases, we'll just say other count plus equal 1. And so then I can say here, print, let's say, vowels, vowel count. Actually, let's just do it in 3 separate lines to make it a little easier and nicer. And then we'll say here, digits, other count, and digit count. Okay. So if I now say this is a test punctuation, this is my, let's just say this is test number 4, exclamation point. So it's going to say there were 5 vowels, 1 digit, and 16 other, which seems pretty right to me. I mean, I'm not going to count it, like test it, but who tests their software? Please, that's why we have users in the world, yeah? Or so I've heard from commercial software companies. So this is how we're doing. Now, there are places where this might fall down or not quite give us the answer we want. Watch this. If I say here, is this a test? Watch what it's going to say. It's going to say there are 3 vowels. Let's check that. Well, I is a vowel, and this I is a vowel, and this A is a vowel, this E is a vowel. Wait a second. There should be 4 vowels, right? But computers, remember the old saying that I was taught years ago, computers do what you tell them, not what you want them to do. In this case, I said, tell me, is the character in AIOU lowercase? But we had a capital I there. Capital I, lowercase I, as far as the computer is concerned, totally different. So how can we fix this? Well, one easy fix is to say AIOU, right? Like make it all capital there. Another fancier way to do it would be to run a method on one character. Say if one character dot lower, the lower method on a string returns the same string, but in all lowercase letters. And so then it will force the comparison to be in lowercase. So now if I say, is this a test? Now it'll say vowels 4, sure enough. And this is exactly the same sort of thing that happens in commercial software all the time. If you find that your program works all the time, except if you do such and such to it, it's probably because they didn't check all the possible cases. And you know what? It's probably impossible to check all the possible cases. Just the way it is. Okay, onward to question 2. If people have questions about this, just let me know in the chat there. Oh, I see here. Is there a way to add color to each digit? Oh, so the answer is, okay, excellent questions. So in terms of color, you can actually print output color, but that is such a complex thing, you would be surprised, because every way of displaying it, whether you're in a web browser or in a terminal or in a GUI, has its own different way of doing colors. There is, I'm trying to remember, there is a third-party module or package for Python that does colorizing really easily. I've almost never used it, but when I discovered it a few years ago, someone told me about it, I was really floored, but I don't know what it would be called, I'm sorry. Changing font size, now you're getting super fancy, right? Adding images, all of these things are possible, but then you're sort of saying, okay, I want to have this data, but I want to represent it, display it in a different way. I can tell you, you know how they always say, I'm not sure if this is true or not, but the saying is that 80% of your brain is used for visual stuff. I promise you that the moment you start dealing with colors and fonts and visualization, 80% of your program will be on all that visualization stuff. And it's a mess and it's hard. So I try to stay away from it as much as possible. But it's all possible, right? Like look at my computer. I've got a web browser. I've got fonts. I've got colors. Mohammed asks, how about input strip lower? Oh, so what if I were to say here, input dot strip? Okay, so the answer is, as always, yes, but, or yes and no. Could I take the user's input, strip it, and then say dot lower? Absolutely 100% yes. Would it give me the same results? Absolutely 100% yes. And by the way, notice I have to use the parentheses both here and here because I want to execute the functions. I want to execute the methods. No parentheses, no execution, bad news. But the thing is, if you lowercase it here and then later on you want to print out what the values are, you've lost what the user originally wrote. So my suggestion is generally don't throw away what the user wrote and don't change it, but keep the lower somewhere else where it's not going to affect that original input. And Larry says, strip didn't work, yet use replace. And the reason is probably, I'm guessing, because strip works only on the outside. It doesn't work on things in the middle. So if I say S equals A, B, and C, then S dot strip will remove the white space, in this case, space characters, from the outside, but it won't change the spaces on the inside. And that's not what it's supposed to do, right? The strip is just supposed to sort of remove all the stuff on the outside, because that's really what you usually want to deal with. Okay. On to question 2. If people have more questions and comments, that's good. Ask the user to enter their name. Print a name triangle. Oh, this is one of my favorite things to give people because I'm an evil person. Also, I never was good at geometry, so this is a good way to get back at the world of geometry. Okay, it's like I remember as I was doing my PhD dissertation, my advisor was like, "Oh, you know, you're not writing this very well. You should really write this sort of logically, you know, like a geometric proof." I'm like, oh, geometry, I was never good at that. All right, so now that I've finished formatting the comments and telling you about my childhood, so what I want to do here, I want to say name equals input, enter your name. And I'll even do a strip here to get rid of the things on the outside. Then what? So if I run this and I enter Reuven, what I want to see is I want to see then R, R-E, R-E-U, R-E-U-V, R-E-U-V-E. Good thing I have a short name, right? R-E-U-V-N. So what are these things? Well, this is basically going to be name until, from the beginning, until 1, because it includes character 0. And then here what I want to do is name until 2. And here what I want to do is name until 3. And you're starting to get it, right? So basically what we want to do here is we're going to need a loop. We're going to need a for loop. We're going to need that for loop to basically say, all right, let's go starting from the first character until the last character. So I'm going to put all this in comments here. Let's see if we can do this. So I'm going to say here, for, well, for what? I could go through each character, but I don't want to do something with each character. What I want to do is get increasingly large numbers, starting with 1 and then up to, well, the length of the name. So what if I were to say here, for, let's say, you know, counter in, and we can say here, range len name. Whoa, that's kind of complex, right? Okay, so what's going on? I'm taking name, I'm taking the string that the user gave me, and I'm calculating the length of that name. That's going to give me an integer. I can then use the range function to say, I want to run the for loop that number of times. What this means is run the for loop the same number of times, or as many times as there are letters in name. That's what we're saying here. So for counter and range, len name, and then I can say print name until counter. Fantastic, except it won't quite work. Huh. So what's going on here? Well, remember that range starts at 0 and goes up to, but not including the value that we gave it. So we said the len of name here is 6. So what we're saying here is range 6. That means goes 0, 1, 2, 3, 4, 5. Oh, yeah. So if we're saying until that, that's not good. But what if I were to say, and also notice that we have like this one blank line here. But all I need to do is then say counter plus 1. Aha. And then it works great because now I'm not iterating over the range 6. I am iterating over the range 6, but I'm taking each number, adding 1 to it, and that's going to be one past what I actually want to retrieve. And that's how I can get my name triangle in there. Okay, questions or comments about this? Okay, on to question 3. By the way, I've gotten a little better, I hope, about answering questions in the forum. So I hope everyone will be like encouraged to try things out, post them, exchange ideas, suggest things to each other. I find that to be really good. And I'm also trying to be there and saying more things now that my book is really, really, really close to being done. I just actually heard from the publisher yesterday that it's going to be typeset in the next few days, and then I will be able to go over it and find last mistakes. Okay. Ask the user repeatedly to enter numbers. How many numbers? We don't know. If we don't know, we can't use a for loop. We have to use a while loop. And moreover, we have to use an infinite while loop, while true. I'm going to say while true, ask the user to enter something. So, hey, number equals input, enter a number. Excuse me. All right, I'm going to say here's strip. And then what? Well, now I want to double check. Is this a, oh, interesting. Thanks, Anna. That's really cool. So basically what I can do, okay, interesting. So what I'm doing here is, I'm starting off with a number. I want to check, did I get a blank string here? So I can say if number equals blank string, break. That means get out of the, or let's just say, exit the while loop right away. Okay, other possibility, maybe it's a non-number. So I can say elif number is digit. So let's flip that logic, not number is digit, print number is not a number. Try again. And then else, in all other possibilities, then we can say here, total plus equal int of number. But wait a second, I don't have total defined, do I? No, I do not. Total equals 0. So what are we doing then? So we're saying, okay, we know that we're getting a string because input always returns a string. So we're saying, okay, is this string blank? So get out of here. Is the number not a digit? Scold them. In all other cases, add it. Now, another way we could do that, by the way, is we could say here, continue. And if we do that, then we actually don't even need the else here. We can even say here, if. Because we know that it's not going to be both. So if number, I think I like this one better, actually. If it's an empty string, break. If it's a non-digit, scold them and continue. And otherwise, we add to the total. And then we can say here, print total is total. All right, let's try this. 12, 58, ABCD, 1B, 39, enter. And the total is 109, which does indeed seem to be the case. Okay, and once again, we're using a while loop because we don't know how many times we're going to want to execute the loop, but we do know when we want to, when we want to finish it. Questions, comments about any of this? Okay, and if you do like, there's plenty of time for more questions. So, time has come to talk about lists. So I want you to think about it this way. All right, strings are, well, we could just say, like, strings contain characters. Right? It makes sense, right? Text is made up of characters. A list is a generic container for other objects. A list can contain any number of any type of objects. That's pretty generic, right? Yeah, and those of you who have experience with other programming language, what we would call statically compiled programming languages, this seems super weird. And I come at from the opposite perspective, which is when I see a language that says, oh yes, we are going to allow you to have, I don't know, an array of strings, an array of integers. I'm like, oh, come on, just give me a list, right? Lists are nice and generic and they work with anything. So how do we do this? So we can define a list with square brackets and comma between elements. So I could say here, for example, my list equals square brackets 10, 20, 30, 40. There we go. And if I say, hey, Python, what is the type of my list, right? What data type is this? It'll tell me, oh, it's a list, right? So my list is a variable that I defined, and it refers to a list value. Okay, I'm gonna actually switch over to the Python tutor now. And I'm gonna do that because I think it's really helpful when we're working with lists. Strings, yeah, integers, yeah, lists, big time. So I'm going to actually visualize code. I'm gonna go to the live coding, because I find that to be really like dramatic and effective. Okay, and slow. Okay, come on. By the way, someone said, I think it was a week or two ago, that they went to, oh, I want to do like programming mode. They went to the Python tutor site and they like ask for help from someone there, because there's this thing now, as about a year or two ago, where you can ask for help from people, and apparently the people were really rude. I'm sorry, like I've never asked for help there. Also never, actually, once or twice I guess I gave help. In any event, don't worry about it right now. Okay, so I'm going to say here, my list equals 10, 20, 30, 40. Watch what happens. My list is a variable, and it refers to a list object, and that list has 4 elements in it. And notice, each element has its own index, starting with 0, just like strings. So if I say print my list of 0, and print my list of 1, and print my list of 2, and print my list of 3, look what we're going to get printed out. The thing at index 0, the thing at index 1, the thing at index 2, the thing at index 3. What if I say print len of my list? That's going to work also. It prints out 4. So you can see that we could use many, many, many of the same things as we did with strings with lists. But of course, my list can contain whatever I want. So I could say 10, 20, 30, 40, hello, out there. And look at this. Our list now contains, right, 7 elements. 1, 2, 3, 4, 5, 6, 7. The first 4 are integers, and the last 3 are strings. Now, I'll tell you right now already that in Python, traditionally, lists are supposed to contain all elements of the same type of data. So what I did here is technically 100% okay, but traditionally in Python, typically in Python, you don't do this. Typically, you'd have a list of integers or a list of strings. Oh, and Larry asks, is a list an array? One of my favorite questions. The answer is no. So why? Well, like, what's the difference? Because many people look at this and like, oh, this is an array. Why are you using this fancy term list? Fancy term, right? Because we're like, it's a 20% savings in the number of characters in the word. So what's the difference? So an array, for those of you who are used to that from other languages, know that an array is like similar to a list. It's a bunch of elements of the same type. So what's the difference? First of all, an array can only contain one type, and that's not the case in Python. A list really can contain any types that we want and a mix of any types we want. The second thing is that an array has a predetermined size. You have an array of size 10 elements or 20 elements or 50 elements, whatever it's going to be, and you can't change that. A list, by contrast, can change over time. We're going to see that in a little bit as well. Yeah, exactly. Well, it's not only that lists are mutable, right? But like they're just not arrays. But we use them in Python as our sort of generic containers for multiple things. So where you would use an array in another language, you would use a list in Python. That's definitely true. Okay, so I can do all sorts of stuff here. By the way, there are many things that I can do with a string that I can also do with a list. So I can say, is something in, like is 30 in my list. I'm going to put this all, I'm going to put this on the Python tutor. Sorry, not the Python tutor, in, what's it called? Jupyter. So it'll be a little easier for you to see afterwards, right? So you retrieve things. Let's do this. You retrieve via index with 0 being the first element. And by the way, this also means we can do slices just like with strings. So I can say here, right, slices work too. I can say print, or I can even do print here, print from my list from 1 until 4, right? And that works just fine. I can print the len of my list. I can just do the len of my list. Oops. It's kind of convenient on Jupyter. You don't need to do the print. You can just get the value here. I can say, is something in my list? And that'll return true or false. So you're seeing a lot of things that work on both lists and on strings. I can also say, for one item in my list, print one item. And sure enough, lists know how to behave inside of for loops. Now notice the difference, right? If I say here, my list equals A, B, C, D, E, F, G, H, I, J, K, L. For one item in my list, print one item. So a string in a for loop gives us its characters one at a time. A list in a for loop gives us its elements one at a time, whatever those elements are. All right, and that is a bit of a difference. I can even do this. I can say here, my list equals 10, 20, 30, 40. And I can say big list equals my list, my list, my list. Big list is a list. How many elements does it have? If I say, hey, what's the len of big list? What is the length of big list? How many elements does it have in it? It actually has 3 elements. Oh, Mohammed is asking a question. Len of my list, it counts only integers. No, that's not true. That's not true. It counts, I don't know where you're seeing that. Oh, here, len of my list, because I defined it to be 10. Oh, goodness. Oh, I didn't redefine it. Ha, sorry about that. That must have been super confusing. I apologize. Sorry. Thank you very much for counting me out on that. No, it definitely counts all the things. So the len of big list is 3. And you might be saying, wait a second, but big list contains 12 things. No, 3 times 4. Let's put this back in the Python tutor. You're going to see what's happening there. Watch this. My list is 10, 20, 30, 40, and big list is 3 references to my list. This right here is where programming starts to get complicated. Because basically big list contains 3 elements, and each of those is an alias to my list. Big list 0 and big list 1 and big list 2 are exactly the same thing as my list. Okay, so it's sort of like, I remember when they invented the like the desktop metaphor in the Macintosh years ago. And they said to people, it's just like having a piece of paper on your desk. And everyone was like, oh, okay, I understand documents. They said, and folders are like where you put documents on your desk. And it was like, oh, okay, that makes sense. And then you could put folders into folders infinitely deep. And people said, wait, you can't do that in the physical world. And the computer scientists were like, yeah, okay, so the metaphor breaks down here. So lists are sort of like a folder on your computer where you can put one inside of another, infinitely deep, as much as you want. And Python will keep track of this for you. But it gets even better than that. Let's go back to Jupyter here for a moment. If I say S equals a string A, B, C, D, we know that S of 0 is A. What if I try to say S of 0 equals exclamation point? Right? Try to change S of 0. And that will not work. And that does not work because strings are immutable. They cannot be changed, ever, ever, ever. But what if I say my list of 0 equals exclamation point? That works. That succeeds. Succeeds because lists are mutable. They can be changed. This is what Pota was writing before in the chat. This is the first data structure we're encountering that is mutable in Python. And this leads to a lot of interesting things because now I can say, well, let's take a look at my list. And we see that my list is exclamation point 20, 30, 40. Oh, here, let's like redefine this here. Sorry. We're really not executing things in the right order at all. Okay, so that will work or that won't work. And this will work. And my list is now going to be, there we go, exclamation point 20, 30, 40. We changed my list. And here's the real magic. Look at big list. That changed too. All 3 of the things here changed too. What the heck is going on? Well, first of all, this is what we in the consulting community call a business opportunity. When people get stuck with places like this. But this is really, really important. And this is where things start to get complex, as I said. Because what it means is you can have data in a list and someone can change it and it'll affect other data that's also referring to it. This is why there are actually programming languages in which everything is immutable. And the people who write and use those languages say, so much safer. Yeah, but it's such a pain in the neck to use. So like there are trade-offs everywhere. So what's going on here? Well, let's take a look. If I now say, think of it, my list is this list, 10, 20, 30, 40. Big list is 3 references to that. You can think of it again as like pronouns. Big list 0 is like, oh, whatever's in my list. Big list 1, whatever's in my list. Big list 2, whatever's in my list. So if my list changes, my list 0 equal exclamation point, look what happens now. My list changed, and now big list 0 changed. Big list 1 changed. Big list 2 changed. It's hard to exaggerate how important this is. And if you're like, okay, things change. Like, why is he making a big deal out of it? It's because it's really important. It's because it leads to a lot of bugs. It leads to a lot of confusion because you can have then these complex data structures. Imagine already, and we're going to start to look at this a little more, certainly in the next, today and then the next time, we're going to see that you can create complex data structures with lists containing other lists and really structure data and work with it in all sorts of really cool ways. But it also means you have to worry about who is touching it and who is modifying it. And people can and will do all sorts of weird things. Usually not on purpose. So lists are mutable in this way, but they're mutable in other ways too. We can change them. So if I say my list equals 10, 20, 30, 40, right? So my list looks like this. I can change individual elements. I can say my list of 2 equals, this is exactly what we just did, a bunch of exclamation points. And now my list is that. Fine. But I can also say my list equals 10, 20, 30, 40. And then I can say my list append 50, meaning add the int 50 to my list. And now the length of my list has changed. That, here, to answer Larry's question from before, again, this you can't do with arrays because lists can change over time. They're like accordions, right? They can grow bigger and they can grow smaller over time. There are actually ways to remove elements. You remove it by location and you can remove it by value. And this is a game changer. So how would I use lists then? Why would I use them? Why are they so important? Because I hope you're already starting to think, well, yeah, there are all these places where I could and I'll want to keep track of stuff. So here's a simple example. We'll probably come back to this a bunch of times. Oh, can you change the order inside of a list? The answer, of course, is my favorite answer, yes and no. You can, and there is actually a method for doing that. Here, I'll show you. If I say my list equals 10, 30, 20, 15, 3, 7. Oh, Ada, great question. I'll get back to that in a moment. So if I say here my list, so my list is this, I say my list.sort, and this changes my list, ordering the elements. So now if I look at my list, you can see it's an increasing order. Okay, so that's a way in which you can change the order. You can even say if you want my list.sort of reverse equals true, and now in descending order. And this will work, by the way, with numbers. Will also work with strings, but you can't use both in the same list. You can't compare those. All right, so Eda's question is, can we modify my list for big list? The answer is yes. So if I say my list equals 10, 20, 30, 40, I say here big list equals my list. Oops, my list, my list, my list. Okay, so if I look at big list, now imagine this. It looks like we have copies of my list here. This and this and this. But they're not actually copies. They're just references to the same thing. They're aliases for one another. And indeed, my list is the same as big list 0, is the same as big list 1, is the same as big list 2. So as Ada was suggesting here, or asking here, I could say my list of 0 equals exclamation point, and sure enough, that changes my list, and that changes big list. But I can also say big list of 1, let's say, equals question mark. And now I've changed big list. I've also changed my list. If you're saying, wait, what the heck is going on here? Okay, I'm saying, hey, big list, I want the thing at your index 1. That's what we're retrieving. What do we get back? Well, 0, 1. We got back this list. This turns out to be the same thing as big list 0, big list 1, and big list 2, and my list. And then we said, okay, big list 1, give me your item at index 1 and replace it with question mark. Yeah, it's pretty wild stuff. Pretty cool and dangerous. But again, like good for consultants. So I'm all in favor. Okay, so you can do all sorts of wild, crazy things with lists. What they're often used for is when you want, they're going to be used in conjunction with for loops. So they're going to allow us to say, get me all of the file names in a directory and delete every file, or back up every file. Give me all the users, all the usernames, and double check their permissions are accurate. Give me all the IP addresses and check that we have connectivity. Give me all the letters of the word and check which ones are this, right? Oh, I guess letters of the word would be going through a string, but you could say, give me all of the, I don't know, you can think of all sorts of other things. All the heights of the people in a building and give me the average. All sorts of wild, cool stuff. And a lot of things in Python are designed to work with lists. They're designed to use lists as collections in many, many ways. Now, a few more things about lists, and let's do like maybe, in fact, let's do this. All right, I'm gonna give you, and I know I usually don't give enough time for exercises. I'm gonna give like maybe even 3 to 5 minutes for this. That might not be enough time for most of you. That is okay. I don't want you to feel bad, but here's what I want you to do. What I want you to do is create an empty list. Actually, I'll even show you what you can do. I can say my list equals this, right? That's, creates an empty list. and assigns to my list. Okay, so I want you to create an empty list. And then let's do this. You know what? Here's what we're going to do. All right. You know what? We're going to do this in two parts. Create a list containing several integers. All right. And then use a for loop to iterate over the list, totaling the numbers. Okay. And then what I want you to do is print the total and the mean, or the average. Now, how are you going to get the mean? Well, you're going to have the total, and think of it this way, you also know how to get the length, right? Right? Remember, len of my list returns the length. All right, so I'll give you like, I'll give you a few minutes to work on this. We'll give you like really 3-4 minutes. If it's not enough time, don't feel bad. But I want you to at least think about it a little bit. You can even write it out what's called pseudocode. Pseudocode is like, I know it's not like executable on a computer, but I know like, but I can sort of figure it out. Mean people are just average. Yeah, I'll tell you. So I just recently in one of my newsletters wrote something about how there's this thing called the Lake Wobegon effect. So Lake Wobegon is this fictional place in Minnesota that was in a radio show for many, many years, a prairie home companion in the United States. And they would joke that all the people in Lake Wobegon are above average, right? And the joke was, of course, right, not everyone can be above average, right? So basically, I mentioned this in one of my newsletters, and someone emailed me. He said, well, it's not funny because really you meant to say median, not the mean. Oh my God. Okay, this is what happens when you have computer people on your mailing list. But yeah, but they haven't updated their jokes, so I'm not going to update mine either. All right, so I'm going to give this another like 2 minutes or so. At least think about it. Think about how you would do this, what you would do, and then I'll go over. I'll show you some more fun, cool stuff we can do with lists. All right, we'll give this another minute or so for people to think about it, and then we'll go over it together. Okay, let's go over this. So I'm going to create a list with several integers. So I'm going to say my list equals 10, 15, 23, 79, and 12. Very exciting. So now I'm going to use a for loop to iterate over the list. I'm going to say for one item in my list. And I'm hoping that this is starting to feel more natural. Like, oh, just like I can go through a string, I can go through a list. And that's part of the idea here. I think I might have mentioned on the first day of this course that Python is considered to be one of the more sort of the easier to learn programming languages. because it's so consistent and because it applies the same ideas to many different data structures. Sort of like the Esperanto of programming languages. Once you learn that something works, you can apply it everywhere. And that's certainly true for for loops. We're going to see for loops basically everywhere moving forward. So for one item in my list, well, I want to total it, right? So I'm going to say total, oops, come on, total equals 0. For one item in my list, total plus equal one item. And now I can say print, right? So the total equals total, and the mean equals total divided by len of my list. And sure enough, we're going to get here the total is 139, which would appear to be the case, and the mean is 27.8. Now, it turns out that there's also a sum method, sum function in Python. So we don't really have to do this, but it shows you how you can use lists to iterate over things in all sorts of ways. Now, if we had a list of strings, of course, we wouldn't be able to like total them this way, but we would be able to do other things to them, like each of the words. Okay? Questions or comments until here? Okay. So it turns out we can get lists in all sorts of different places. And I want to really show you like an example from the real world of where lists come in, where this is all going to start to come together. So here's what I'm going to do. I'm going to say here, let's do this. Let's say here, I'm going to say import OS. And this means you use the OS, or like the operating system module in Python. Now, we haven't talked about modules at all yet. That's going to be like on the last day of this course where we're talking about modules. But you can think of them as collections of functionality that other people have prepared for us. And many of these modules come built in with Python. OS comes built in with Python. And if I say os.listdir, listdir is a function in the OS module. And it returns a list of the files in a particular directory. So I'm going to say /etc. That's one of my like favorite places to retrieve things from. It's a Unix thing. If you're not on a Mac or in Unix, you can search elsewhere. You can even say dot to say the current directory if you want. Don't worry about it. And I'm going to get what? That's right. I'm going to get a list of file names in that directory. So what can I do with that list of file names? Well, I can print it out, right? I can say here, for one file name in OSLister /etc, print one file name. And sure enough, now we're going to get the list. We're going to print out all of these file names. All right. That is what every time you use the dir function, dir command in Windows, or the ls command in Unix, it's starting off doing. It's asking the operating system, right? It's saying, hey, can you give me a list of the files in this directory? It's sort of like, no, it's like /etc is the configuration directory in Unix systems, but it doesn't really matter. You can use whatever you want. But you would probably need to use backslash. Yeah, you need to use backslash stuff for. Well, actually, you don't even need to. It's a whole long, complicated thing. But you can use you need to use backslashes if you learn somewhere. And this is going to give you a list of all of the files there. And the lower level things in the system are doing the same thing. Well, this is kind of boring, right? Like just getting a file listing. I want to do something a little more exciting. What if, okay, this is not really that much more exciting, but how about this? I want to find out what is the average length of a file name in the etc directory. Huh, right? Something I've always puzzled over. I could never sleep at night. So what's the average length of a file name in etc? Well, how can we solve this problem? Well, what I can do is I can say import OS to get that module. For one file name in OSLister etc. I can say here total, or I can say here length equals a list. And watch what I'm going to do now. I'm going to say here length append len one file name. Whoa. Okay, let's think what we're doing here. os.lister. I've gotten a list of strings. What are those strings? Those strings are file names. Each of the file names in the etc directory. So I'm going to go through them one by one. And as I get each file name, I'm going to stick it into one file name. What am I going to do then? Well, then I'm going to find out what is the length of that file name? What is the length of the string, the name? And then I'm going to take that number, that length, and I'm going to append it to the lengths list. And so now if I look at lengths, what do I have? A long list of integers. Well, how can I get the average length of a file name? You know what I'm going to do. I'm going to say here, total equals 0 for one length in lengths. total plus equal 1 length. I can say here print average file name length is, and we'll say here total divided by len lengths. And the average file name length is 12.42 characters long. That's pretty long. Now, the particular task we had here is not the important thing. The idea is that we have done this now. We have used these tools, these simple tools as building blocks to suddenly be able to do something practical and useful. I mean, some people practical and useful, right? Okay. Any questions until here? And by the way, you see how I use the list twice now. So I build up the list from nothing with info collected. And then here I said, right, iterate over the list to get the total length. Right, so I used a list here in 2 different ways, but in both cases I was using a for loop to do it. Okay, let's look at 1 or 2 other things we can do with lists. Yeah, actually, we got about like 15 minutes or so. Oh, can we use sum instead of append? Yeah. So actually, Krishnendu, I'm sorry if I'm not pronouncing that correctly, asks, can we just use the sum function instead of all this? And the answer is yes. So basically, what I could have done if I wanted to be lazy, which is of course a good thing to do, I could say here I could just say I could get rid of all this. Come on. I could just say here average file name length is sum of lengths divided by len of lengths. Sum of lengths, and get rid of total altogether. And that would work exactly the same way and should give me, yes, indeed it does, give me the same answer. Absolutely. So in a real program, I would definitely use this instead. Actually, there are even better ways to do it, but that's not an issue. Okay. What about lists of strings? Or what about lists of integers we get from the user? Right? So what if I were to do this? What if I were to say here, ask the user to enter a bunch of words, 1 at a time. If the user enters, an empty string, stop asking, and then print the average length of the words they gave. So this is similar to what we just did, but now, excuse me, we're going to be getting input from the user, and we're not going to get it all at once. We're going to get it one little bit at a time. So how are we going to do that? Well, we'll need to say here, while true. Why a while loop? Because we don't know how many the user is going to give us. And I'm going to say here, right, s equals input, enter a word. Let's do that, strip. Say here, if s equals the empty string, break. So we're going to break out of that. Otherwise, what I'm going to do is, here, let's do this. I'm going to say here, words equals an empty list. I'm going to say here, words append of s. Actually, I should probably do append of len of s. Let's do this. We'll say here, lengths. Right, and I'm gonna show this through the Python tutor in a little bit because you'll see how it grows over time. Then we'll say print, right? Print, average length is, and we'll say here sum of lengths divided by len of lengths. So if I say here ABC, DF, G, HI, JK, LM, and OP, enter. So it says the average length is 5.3, and I'll believe it. I'm going to pop this in the Python tutor so we can see how this works here. I'm going to do this little by little. So visualize execution. Very good. So it says length is an empty list. Sure enough, length, empty list. And it's going to say, okay, now enter a string. So I'm going to say hello. Okay, so S is now the string hello. Is it the empty string? It is not. So now we're going to append to lengths the len of S. And now you see that we've added an element to our lengths list, 5. Okay, and now I can say here, goodbye. Submit that. Is that empty? No, it is not. So we're going to append its length to there. I can say, whatever. Right, and so we do that. Let's append there. So as we add words, we're appending, and now I can just do here, submit, to give me an empty string. Is it empty? Yes. And so now we're going to print the average length, and the average length is 6.666, and so on and so forth. But you see how our list is growing over time, how we're able to use it as a sort of a temporary storage to keep track of things, which is pretty useful and good. Now, of course, we could do all sorts of things here. We could say, well, maybe I want to make sure that it's actually a word that's got this length, that's got these characteristics, and so on and so forth. Questions or comments about any of this? Okay, a few other methods we can do with lists, which are kind of fun. So we saw sorting already, right? And sorting, here, watch this. If I say here, for example, watch what I can do here. We already still sort, but I want to show this to you. So I'm going to ask the user, I'm going to use exactly the same code as here, but instead of getting the lengths, I'm going to get the actual words. So here I'm going to say words is an empty list. While true, get the input. We're going to say words append s. And then I want to say, I want to print. So we're going to ask the user to enter words one at a time. When they enter an empty string, stop asking and print the first and last words alphabetically that the user entered. Ooh, now this is getting tough, right? Because what's happening? The user is going to enter a bunch of different words. And then we have to say, oh, which one is the first alphabetically and which one is the last alphabetically? You know what? Lists make this easy. So I could do this. I'm going to do this here. I'm going to say here, right, this is a test sentence broken up into many words. Enter. So if we now look, we'll see that words is a list of strings. How can I get the first one alphabetically and how can I get the last one alphabetically? Well, if we sort the list, the first element is the earliest alphabetically, right? And the last element is the last alphabetically. So if I now say words.sort, and then I can say print, right, first word is words 0. Why word 0? Because the list has been changed so that the thing in element 0, right, 0 is the first index, remember, is the earliest one alphabetically. And print, right, the last word is words -1. Remember that -1 gives us a lot, when we use negative indexes, we count from the right. And the first word is A, and the last word is words, and that would appear to be the case based on my initial scanning of this as well. So once you put things into lists, you could do all sorts of really cool things. So you can have lists of numbers. You can have lists of strings. You can even have, as we've seen, lists of lists. And we're going to talk about that a lot next time when we talk about splitting and joining and how we can play with stuff there. Can I remove things from a list? Yeah, I mentioned this earlier. So if I say here, my list equals, let's do this, 10, 20, 30, 40, 50, 60. So I want to show you how we can remove based on value and remove based on location. Then I'll show you how we can add multiple things to a list. I think that'll sort of close out our time. So remove based on location, how can I do that? Well, I can say mylist.pop. And this means remove and return the element at -1. And so 60. So we got back 60. And now if I say, hey, what's in my list? Look at that. Now it's been, the final element has been removed. If I say mylist.pop, sure enough, it's returned 50. And now if we check my list, that last element is gone. This is, remember I mentioned earlier, lists are sort of like accordions. So append allows us to grow them, and pop allows us to shrink them. And if you're wondering, what the heck with pop? So if you think of, there's a classic data structure in Python known as a stack. And when you put things onto a stack, you push it on. And when you retrieve it, you pop it off. And a stack is known as a LIFO, last in, first out. You think of it as a stack of papers, or people like to compare it with, if you've ever been to a cafeteria with the plates on springs, where the last one that was put on is the first one that people take off. That's the sort of analogy they try to use. In any event, so the way that you remove things from a stack is with the pop function or method. That's what they use here in Python. But what if you want to remove from somewhere not the end? So to remove from somewhere that's not the end, use pop with an index. So we can say here, mylist.pop2. And this means remove and return the item at index 2. And sure enough, we got 30 back, which means now if we check, my list is now 10, 20, 40. Right? Now, I must admit, while this is kind of cool, how often do I remove things from lists? Not that often. Not that often. Like, it definitely happens, but I would say it's like, 5% of the time, 1% of the time. It's pretty rare. I add things to a list all the time. And just so you know, you can also remove based on value. You can say mylist.remove of 20. And like this will remove the leftmost item with this value. And so now, doesn't say anything more. And we say here, mylist. Oh, is there any way to retrieve back the item you just popped? Once it's gone, it's gone. So if you say like, let's do this. If I say like, removed equals mylist.pop. Now the most recently removed thing, like, so it removed 40, and now my list is just 10. Right, so, but if you don't do that, if you don't grab it when you pop it, it is gone. The other thing is, how do you add multiple things to a list? So like if I have my list equals 10, 20, 30, and what if I say here, other stuff? Oh, if my list is assigned to another list, do both refer to the same content? Or no. Oh, Peter, excellent question. If let's do this first. Oh boy, this is really important. Okay, so if I say here, my list equals 10, 20, 30, 40, 50, and then I say alias equals my list. So now these are two names pointing to exactly the same thing. If I say my list append 60, so my list has grown by 1. Wait, why does this? That's weird. Huh? Wait a second. Oh, there we go. Okay. I don't know what happened there, but fine. I guess I didn't execute that first. Okay, fine. And then I say, what's alias? And alias is exactly the same thing. And if I say here, my list dot pop of 3, then my list is going to look like that, right? I've gotten rid of 40. And alias is also, there are two names referring to exactly the same list. So when we invoke append or pop or sort, we are not doing it to the variable. We are not saying, hey, my list, I want you to do this. Rather, we're going through the variable to the object itself. We're saying, object, change yourself. And that change is reflected here. And that's why mutable data can be so dangerous. Okay, now you can copy things. You can say, for example, this would be very different. If I say here, let me just copy what I have here. If I say here, my list equals 10, 20, 30, 40, 50, and then alias equals my list copy, right? This returns a new copy of, or a copy of my list. Same content, but it's independent. Okay, excellent. I mean, there are other ways to do it, but this is something they added a few years ago, which is really convenient. All right, watch this. If I want to add multiple things to a list, so if I say my list 10, 20, 30, and other stuff equals 40, 50, 60, what happens if I say my list append of other stuff? Well, the good news is that Python will do exactly what you asked. It will now append other stuff, the list, to 10, 20, 30. So now what is the len of my list? It's 4. First element, the integer 10. Second element, integer 20. Third element, integer 30. Fourth element, the list, 40, 50, 60. That can be useful, but it's probably not what you wanted. So how can we do this? Well, we're going to need something a little different. To really add multiple things to a list, there are two different ways to do it. I prefer to tell people to use the extend method. All right, what extend means is run a for loop on other stuff. That's what extend basically is doing. Right, so extend runs a for loop on other stuff, appending each item to my list. That's what's basically going on here. And sure enough, 10, 20, 30, 40, 50, 60. So you can see how we can add a list to a list as an individual element, or we can add each of its elements. You have to think about which one you're doing. Classic example, watch this. If I say my list equals 10, 20, 30, and I say my list append A, B, C, D, what's going to happen? That's 10, 20, 30, A, B, C, D. But if I say my list extend E, F, G, H, what's the difference? The difference is that here extend ran a for loop on the string E, F, G, H, and each one of those was added to the list separately and distinctly. Okay, and so now strings are really useful in that sense that we can sort of see very obviously and visually what happens when we add them as one thing and when we add them as multiple things. You can also, by the way, I mentioned that like sometimes you can do other things. You can also use plus equal is almost identical to extend. So you could say here my list equals 10, 20, 30. You say here my list plus equal 40, 50, 60. And then my list now has 10, 20, 30, 40, 50, 60. Okay, so lists are used all the time, everywhere, especially with for loops. Not only, but especially with for loops. And lists of strings and lists of integers are just like everywhere in Python, but also lists of other kinds of objects. And what you can even start to do with lists is put together what we would call complex data structures. So imagine this. Imagine I have a list of lists where every inside list is a last name and a first name. Then I have a little phone book, right? Or a last name, a first name, and an email address and a phone number. So you can start to structure your data, and you can start to search inside of it using a for loop, retrieve from it using a for loop. This is why for loops are so important, because they allow you to go through everything in a list and search for things and decide things. Can you duplicate numbers? Oh, yeah. Oh, I'm sorry. So glad you asked. Yes, absolutely. Lists could not care less. My list equals 10, 10, 10, 20, 20, 30, 30, 40, 40, 50, 40, 30, 10, 20, whatever. My list, absolutely. Whatever you throw at it, it is happy to have. There is another type that we're not going to talk about in this course called a set. And a set is similar to a list in many ways, except that it does not allow you to have duplicates. And that's like, you use it for specific things where you want to make sure that the contents aren't duplicated. Other questions about this stuff? What if you want to sort the list not in place? Sakiro, great question. So the fact is that it's actually considered nowadays a little passé to sort things to use the sort method. What we have is, instead of using the sort method on a list, you can, I would say many people nowadays suggest using the sorted function. Now, I realize it's confusing. You have the sort method for lists and the sorted function, which is like not attached to it. And I could say that my list equals, let's say, 10, 5, 30, 2, 12, 15, 6. And I'm going to sort it of my list. The difference is this one returns a new list, sorted list. And it just returns a new sorted list, right? It does not touch the original one. And so here I'm going to get back 2, 5, 6, 10, 12, 15, 30. But what happened to my list? Absolutely, positively nothing. And so sorted is considered more modern, more elegant, because it does not change the original one there. And sorted actually, so the sort method only works on lists, because methods always belong to a certain type of data, where sorted works on anything. You can even use sorted on a string, sorted on C, B, A, and you'll get back the list A, B, C. Notice it gives you back a list. Sorted always returns a list. Whereas, yeah, there you go. Other questions or thoughts that people have, maybe I can help you with. For average length, how do you round up to limit the, so I just discovered this a few weeks ago, the round function. I think I even told people here, I was telling people somewhere. Round, and you tell how many digits. So watch this. If I say here like round of 1, 2, 3, 4. Well, I think it rounds it to, I think it always returns, let's see. Well, what if I say here, and if I say like 2. There we go. So what I could do is I could say like, let's do this. So I have my list. Yeah, perfect. I could say sum of my list divided by len of my list. That'll give me the average. But I can also say, this is great. This is perfect. Round sum of my list divided by len of my list. So we're going to take this float and we're going to hand it to round, and round is going to round it off and give us an integer. But what if I don't want an integer? What if I want some number of decimal places? Then I can pass the optional second argument. It says, actually, I want 2 decimal places, and it will do just that. What never ceases to amaze me is that the Python developers, I guess because they have this sort of 30,000-foot view of what people are doing, and they're always exposed to what people want to use the language for, they're sort of able to predict what people want to do with the language, and they stick that functionality in there. So it's always amazing. Like, I'm constantly discovering things that they put into the language that I really found it later on. Oh, is it really rounding formatting is round? So it is returning. Good question. Vinicius. Oh, I hope I got that right. Vinicius. So what it's doing is it's returning a float value based on its inputs. So it doesn't know that we have a list here. It doesn't know we have a list there. Round, as far as it's concerned, is just getting a float value. And it's returning a new float value based on that. So it's not just formatting, it's returning a float value. We can do whatever we want with it, including printing it. Okay, other questions or thoughts, anyone? Okay, so we're gonna conclude here for today. I'm gonna put some questions. I'm gonna upload the video, hopefully today. Again, might be Saturday night or Sunday morning. Probably Saturday night, Sunday morning. I will put some questions into the forum. This is where, as I said, things start to get a little wacky and where they start to get a little hard. So I'm gonna give you a bunch of homework assignments. If you have not yet received an invitation to the forum, I usually send the invitation to the forum like every 2-3 days. It might be in your spam, your junk. If you did not get one, just email me and I'll be sure to resend it to you. But if you just signed up today or yesterday, then you might need to wait like another day or two because I just batched them. But definitely try to do the homework assignments. And if you have questions or problems, definitely ask for help because this is where things start to get a little hard, but hopefully fun and interesting and more like realistic as well. Folks, thank you so much. I will remind you, by the way, that my publisher, I'll even show you, like my book publisher, they gave me all these T-shirts. When I'm ever going to wear these T-shirts in public, I don't know. My family's like, never wear these T-shirts. This is the cover of my book. Woo. And so Manning Publishers has said that they will give discounts on all their books to anyone in this course. So if you want to buy books from Manning, it doesn't have to be my book. They're fantastic. And I'll put the coupon code that they're offering there for anyone who wants to use it. The link to the forum is at forum.learner.co.il. And if you didn't get access to it, again, just email me and I'll be happy to share that with you. Folks, this is great fun for me as well. I'm glad you're enjoying, glad you're learning, and I'll be in touch with the forum, and I will see you here next week. Thanks, folks. Have a wonderful weekend. Stay healthy, stay safe. Hope you're doing great. All right, I'll see you next week.